You got it, you put on the got it, na? One message will come.
Sir, that is relation by it is coming from because we are having an equation reaction will having equilibrium, and that is dynamic equilibrium means that will have the that will follow the Le Chatelier principle, sir.
Okay. Dynamic. Okay. Let me
The
see.
dissolution process is endothermic, that means solubility should increase with temperature.
Okay. 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 So you are talking about solubility of solid in liquid. What will happen if we increase the pressure? What will happen if we increase the pressure?
Significant change will be there because solids and liquids both are highly incompressible.
They are highly compressible or not compressible?
Incompressible.
Incompressible. Okay, good. Hmm. Okay. So you are saying that is solubility of solid in liquid will increase with increase in temperature and there is no effect of the pressure. That you are saying. Okay. Okay. What the process involved in the solubility? What the process involved? Have you read this one, crystallization and dissolution process?
No, sir, only 2.3.1, whatever is there. That much.
But at the dynamic equilibrium, what is happening? That is dissolution process also involved now. Dissolution. What is dissolution? Can you tell me?
In case of the dynamic equilibrium, the two processes undergo the same rate. That is the first of all crystallization and second is dissolution. Both will occur with the same rate.
Okay. Solubility of solid in liquid. You are telling that is almost correctly you are telling, but few things you are missing. Okay. Not 100% you are telling. Okay. First rule is there like dissolve like. Like dissolve like. Like dissolve like. You must have read this one like dissolve like. What the rule is saying? That is polar dissolve in polar. Dissolve in polar. Yes or no? And the second one is there non-polar. Non-polar dissolve in non-polar. What do you mean by this?
So that means that whatever that the polar compounds will there, they will polar compounds will there, they will dissolve in the polar solids only, and whatever the there. For example, sir, in case naphthalene and anthracene, sir, they are non-polar molecules, and so they will not dissolve in water.
Okay. So here they are saying sugar dissolve in water. What the rule is being applied here?
So because sugar is a polar compound, nah.
Sugar is
Sugar is
polar
a polar
compound.
compound. Sugar is polar compound. It is also polar compound.
Okay. Benzene. Benzene does not dissolve in water. Does not dissolve in water.
Water is polar.
Dissolve in water. Okay. Now, second one is there. There is the two process taking place simultaneously. Suppose you are taking solid and another you are taking liquid. Okay. This is the 9th standard actually. Solid dissolving in liquid. If the solid is going into liquid, what the process is named as? If the solid is dissolving in liquid, what the process is named as? Can you tell me?
Dissolution.
Dissolution. This is dissolution. Okay. And that is from the liquid, if it is in the solid, it is converting in the solid. That is called crystallization. Okay. Crystallization. And that is these two process exist in the equilibrium. When solid dissolve, okay, in the liquid at certain concentration, these two process, okay, occur simultaneously. That is the dynamic equilibrium. So what will happen in this condition? That is the two things conditions are there. One is saturated solution. One is saturated solution. What do you mean by this saturated solution? What do you mean by this saturated solution?
Solution is a solution where no more solute can be dissolved at a particular temperature and pressure.
That is, during the dynamic equilibrium, you are not going to dissolve anything because whatever amount you are going to dissolve in liquid, the same amount of from the liquid is converting into solid. So at the saturated, when the concentration at this saturated concentration, both the process are same, right? And secondly, Unsaturated solution, supersaturated solution, these are there. Supersaturated solution, more than required amount of solute is dissolved. Okay. Unsaturated means that can dissolve more. So these were there. These were the rule were there. What is the interaction? That also you let me. Interaction factor are also there. Interaction. What type of interaction should be there?
Interaction, sir, I don't know. Sir. Interaction.
But you read now, you are saying, see, if I am considering solute, solute should be having interaction, two solute particle having interaction AA. And solvent particle interaction should be BB. So when you are dissolving this one, so it is forming what? Solution. And solution interaction should be what is? A and B. So if all are equal, na, if all are equal, if all are similar, okay, similar, then they dissolve. Then they dissolve. The question they will ask, the question may ask, here the solute interaction equal to solvent interaction equal to solute interaction. If they are equal, then only they will dissolve. Otherwise, they are not going to dissolve. Okay. Suppose this is polar, so it will be also polar. So whatever bond should form, that is again going to be polar. So this will dissolve. Getting? No.
Yes, sir.
Okay. Now see some point. Let me go back. Okay, sorry. Stop share. Huh? If I will go here. 1 minute you give me, please. This is the, what is this? No, this is not required. Wait, Sana. Going here. Cancel out this. Canceling, I will stop. Okay. Okay. Here, the little bit I am taking, because you already read the NCERT. I need to clear some of the point. Otherwise, you will be in the difficulty zone. Then we'll go back. Here you read this one. Vapor pressure, no. This is the gas and liquid. Here this topic is there. Solubility of gas in liquid. Before that, here. But the point are there, that is you are saying, that is you read this one. That is why I just want to discuss this one. Okay. What they are saying, solubility of solid in liquid. That point you saying, that is you have finished this one. Now the first one
Yes.
is there. This one is like, dissolve, like. Okay. This one first. So this point you already clear this one. And second one is saturated solution. This point also we have covered this one. And second one, effect of temperature, you already told me. That is, it will solubility increase. Effect of pressure, that is no effect. Okay, pressure does not affect this one. Now we are going to study the solubility of gas in liquid. How will you define the solubility? First term is very important. How can you define the solubility? Can you tell me? How can you define the solubility?
The solubility is the maximum amount of solute that can be combined with the solvent. They dissolve in a specific amount of solvent in a specific temperature.
Specific temperature. Here they see the solubility. The amount of solute dissolved in given amount of solvent depend upon following factor. This is not the correct one. Here you see solubility. This one is there. So that what you are saying, that is absolutely correct. Solubility of solid in liquid. Here they have said that is what the factor they are saying. Like, dissolve, like. See, this is the solvent is there. Suppose AA interaction. Solute is BB interaction. Solution is AB interaction. So AA, BB and AB. These all must be equal so that it will dissolve. Like, dissolve, like. So that is point is clear. Now, here they are saying dissolution and crystallization process are in dynamic equilibrium. So you will be seeing this one, solute plus solvent. This is the dissolving in solution and they are crystallizing. So they are the interchangeable. This is. Now the next one is, the question is there, define the solute in a saturated solution. That also you got to know. Okay, here is the Le-Chatelier principle, you also know. Okay, so now we are moving to the solubility of gas in liquid. Have you read anything? Solubility of gas in liquid?
No.
Okay, solubility of gas in liquid. But there is one principle involving here solubility of gas in liquid, that is called Henry law. H-E-N-Y, Henry
Sir,
law.
how not
Hmm?
what about the Raoult's law?
What?
The Raoult's law that is not there.
Raoult's law for liquid and liquid in liquid. You are asking gas in liquid now. Raoult's law is for liquid in liquid. So that we will cover just after the Henry law. Okay. So what they are saying, Sanoy, that is when you are dissolving the gas in liquid, you are dissolving the gas in liquid. Suppose any gas in the liquid you are dissolving. So you got to know that is gas will dissolve in liquid very less. Okay, very less it dissolve. So we study this one in term of what, that is mole fraction. Okay, so here the how it is defined, partial pressure of gas in liquid is proportional to its mole fraction, proportional to its mole fraction. So that is what the in term of partial pressure, suppose any gas is there, proportional to it will be the x, proportional to x. And if you are removing the proportionality sign, so P is equal to, it is going to be KHX. Now, if I will ask you what is this X? X is solubility. Solubility. Solubility in term of what? That is mole fraction of gas. Mole fraction of gas. This is there. What is this P? Partial pressure of gas. Partial pressure of gas. Partial pressure of gas. Okay. So this is the how we study the gas in the liquid, solubility of gas in the liquid in the term of partial pressure. The partial pressure of gas in liquid is proportional to its mole fraction in liquid, in liquid solution, in liquid solution, in liquid solution. Okay. This is now. I hope you it will be equation. Did you write the equation? This one.
Yes.
If you are core, okay, let us move. Let us move to the NCRT one, so that you can be able to understand little bit better way this. Now, solubility of gas in liquid. Here you see this one. You read this statement. What they are saying? Many gases dissolve in water. Oxygen dissolve only in a small extent. How much they are dissolving? Very small extent in water. It is this dissolved oxygen which sustain all aquatic life. On the other end, hydrogen chloride gas, HCl, is highly soluble in water. Solubility of gas in liquid is generally affected by pressure because they are the compressible. Now here you see what the point here, pressure and temperature. Okay. Now here you will get the definition will come here in this one. Actually, here you read, they are saying the solubility of gas in liquid is directly proportional to partial pressure of gas present above the solution of liquid. So, or solution, where they are saying it is the depending on what factor? Can you read this one? The
That
solubility gas in liquid directly proportional to partial pressure. Partial pressure is P of the gas present above the surface of the liquid or solution. Proportional to solubility, in what term you are studying solubility? Mole fraction. Partial pressure proportional to mole fraction. So P proportionality sign you are removing. So KHX. This is coming. KH is what is Henry constant. HENRY. Henry constant. Henry constant. X is mole fraction of the gas. P is partial pressure of the gas. Another term you see, mole fraction of gas in the solution is proportional to partial pressure of the gas over the solution. So this is another definition of this one. What they are saying? Mole fraction of gas in solution is proportional to partial pressure of gas over the solution. Are you getting this?
Yes, sir.
Yes or no?
Getting.
Okay, third statement see. The partial pressure of gas in vapor phase is proportional to mole fraction of gas X in solution. So, P proportional to X. So, you are removing the proportionality sign. So, P equal to KHX. If you are correlating this one, Y is equal to MX plus C. So, what you are going? MX plus C, what you will get?
Equal to
That is,
0
this is the
start from
positive
origin.
slope. Positive slope you will get, right? Here is the, are you getting this?
Yes, sir.
Okay. So here you read. What are the factors responsible for this one? We are going to study the factor. Okay. This is the clear, na? This one clear.
Yes.
Factors affecting solubility of gas in liquid. So first factor we are going to study. There are many factors are there. Firstly, pressure. So pressure is proportional to solubility. Okay. So more the pressure, more will be solubility. More the pressure, more will be solubility. Why? Gas is highly compressible in nature. Gas is compressible in nature. So if you are applying the pressure, the solubility of gas in liquid will increase. Yes or no?
Yes.
Okay. Next one. Second. That is why if you see the cold drinks are there, na cold drink. You must have drink the cold drink. In the cold drink, CO2 gas is filled, na CO2 gas. CO2 gas.
Yes.
And this CO2 gas is under what pressure? Under high pressure. Yes or no? Under high pressure. Under high pressure. That is why whenever we open, so much gas comes out. Yes or no?
Yes.
So that is the gas is soluble under high pressure. So pressure increase, so solubility of the gas in liquid increase. Is it okay?
Yes.
Okay. Second one, temperature. You explain the temperature. What should happen? Temperature, if you increase the temperature, solubility will increase or decrease?
Sir, the solubility of gas in liquid should decrease with the rise of temperature.
Okay. Reason?
Reasons are gas molecules present in the liquid spaces are that in case that one, so that means gas molecules should be present in liquid phase. So that is simultaneous condensation, and here heat will be evolved. So by using the Le Chatelier principle, we see that this one.
Okay. But I don't know. You are telling in the different form. Solubility of gas in liquid is exothermic process. What is this one? Exothermic process. Means when you are dissolving the gas plus liquid, gas plus liquid, it is forming the solution, right? It is forming the solution plus heat is releasing heat. Now, what is happen if you are increasing the temperature? So reaction will go forward or backward?
Sir, forward, no backward, backward.
Backward. So if you are going backward, so that is, if it is going backward, so solubility increase or decrease? Decrease. So what the reason you will give? The solubility, since the solubility of gas in liquid is exothermic process, therefore, according to Le Chatelier principle, solubility will decrease. Okay.
Yes.
So first factor we study pressure, second factor we study temperature, third factor is interaction. Interaction. Okay. Interaction means if the gas particle is making bond with the liquid particle, proper similar bond, so it will be highly soluble. Okay. And if it is not making, so it will be less soluble. So now the question first one. The question first one, it become very difficult for the aquatic animals to survive during the summertime. What can be the reason?
So the solubility of gases decrease with the increasing temperature. So that in the summertime the water temperature will increase.
Okay. Now see here, one point you have to understand here. Henry Love find. What Henry Love find here, you will find here. Several application. What are the application of Henry Law is there here? Several application in industry explains some biological phenomena. Notable among these are first one. First one, see. To increase the solubility of CO2 in soft drink and soda water, the bottle is sealed under high pressure. Why it is bottle is sealed under high pressure, Sanay? In the sealed bottle under high pressure?
Maximally increase the solubility.
To increase the solubility. Now, scuba divers is there. Scuba divers must cope with the high concentration of dissolved gases while breathing in the high pressure underwater. So, underwater will the pressure is high. Next one. Increased pressure increases the solubility of atmospheric gases in the blood. So, pressure is high. So, when the scuba diver go in the deep sea, suppose in the deep sea, if the diver went, so what will happen here? What will happen? The solubility in the blood increases. When the divers come towards the surface, the pressure gradually decreases. This releases the dissolved gases and leads to the formation of bubble of nitrogen in blood. This block the capillaries and create medical condition known as what bends, which is painful and dangerous to life. Now, in the deep, if we are going now deep, so highly soluble. No, gas is highly soluble. Now, what is happening? The person is coming out. Again, the person is coming out to the surface. Here, the person come out to the surface. Once it is come out to the surface, what will happen? Solubility is same or decrease?
Solubility is decreased.
Less soluble. So less soluble means gas comes out. The gas is going to be comes out. So at sudden the gas is coming, at sudden gas is coming. So what they have will happen, Sanoy, here they are going to block the capillaries. The blood flow will be stopped. In the body, blood flow is the stop. And this condition create medical, this is called medical condition known as bends. And highly painful condition, sometimes the person get die. Here see, the person get die. Getting my point?
Yes, sir.
Okay. Next point you see. Now to avoid, here you see, the question comes from here. To avoid bends as well as the toxic effect of high concentration of nitrogen in blood, the tank is used by scuba divers are filled with air diluted with helium, 11.7%. Then this is the helium 11.7%, nitrogen 56.2%, and oxygen 32.1%. Earlier, the nitrogen percentage was more because helium we are not taking. Now we are taking the helium also. To avoid which disease? To avoid the Bend's disease. Don't know, are you getting or not?
Getting.
Okay, thank you. Here you see, next one. What the next point they are saying here? At high altitude, the partial pressure of oxygen is less than that of the ground level. This leads to low concentration of oxygen in the blood and tissue of the people living at high altitude or climbers. Low blood oxygen cause climber to become weak and unable to think clearly. Symptoms of this condition is known as anoxia. Suppose this is the earth level. Okay, this is the earth level, right? And here is if you are going after earth level, this is the high altitude. High altitude. Okay. Now the any person is staying here. So go up, that is what is the pressure will be less. Yes or no? Against the gravity you are going, less pressure will be there. Less pressure. Yes or no?
Yes, sir.
So solubility of O2 will be increase or decrease. Solubility of O2 is less. Yes or no?
Yes.
So solubility of O2 is less means the brain or the tissue will not get the proper oxygen. and proper oxygen is not getting, so that is the person may not think properly, unable to think, become weak, and the system is this condition is known as anoxia. Will you able to understand?
Yes.
Sure, or that is was simply saying yes, sir.
So when I have doubt, I will stop.
Okay, thank you. So here is effect of temperature. Once more you read here. Solubility of gas in liquid decreases with rise in temperature. When dissolved, the gas molecules are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved in this process. What they are saying? Heat is evolved. Can you see this point?
Exothermic.
Exothermic. We have learned in the last section that dissolution process involve dynamic equilibrium and thus must follow Le-Chatelier principle. As dissolution is exothermic process, the solubility should decrease with increase in temperature. Is it okay?
Yes.
Okay. Here you go. You see the some question you also see here. What is solubility of there? The point is there here. 1 second, Sanoy. Is it visible to you? The slide is visible to you?
So now we
Why is solubility of polar gas more in water? What is reason will you give? Why
so we have
solubility
just
of? Hmm,
so
hmm.
like attracts light, so that way polar gas will be more easily dissolved in polar solvent.
That is why in the NCRT they have said HCl gas is more soluble in water compared to what oxygen gas. What reason you will give? What reason will you give?
Um,
Oxygen is non-polar. This is non-polar. And HCl is, this is minus, this is plus, this is polar. And water is, H2O is HOS, this is minus, this is plus. This is again going to be polar. So that is what is happening. Polar dissolve in polar. So oxygen is non-polar, so less soluble. Are you getting this?
oxygen
Uh,
non-polar celestial.
so polar solvent, they are saying this is because water is polar, so it can easily dissolve polar gas like hydrogen chloride. In water, oxygen dissolve only small extent. It is this dissolved oxygen which sustain all aquatic life. Now, what is the effect of pressure on solubility of gas in liquid? What is there, Sanjay? Can you see this slide? Here is less pressure is there. So gas you see how many? 1, 2, 3, 4, 5 molecule. But here pressure is more. So number of molecule you see 1, 2, 3, 4, 5, 6. So there are more molecule. This is the gas particle. When pressure you see here the particle are very less. Can you see this one? In the
Yes, sir.
solution, less particle, but here when pressure is more, the solid particle is more. So means pressure proportional to mole fraction. So P is equal to KHX. Can you understand this? Can you understand this?
Yes, sir.
Okay, thank you. Read this one. Can you read this one? Can you? Hmm, 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 hmm.
Sir, what is the question here? What I have to do?
Just the process is there. Just process you were supposed to read in the both figure. Leave it. Very easy. Why do gases always tend to be less soluble in liquid as temperature rise? That you know exothermic process.
Just,
So no.
sir, this is what
Next.
NCRT, sir. If you scroll up a bit, I can show you.
Okay. Next one. You see, state Henry law correlating the pressure of gas and solubility in a solvent. Why? How can you correlate?
So directly proportional.
directly proportional at constant temperature. So this is you can see every year this Henry law is being asked. Okay, this is this one. Now, what is the importance of Henry law constant? What is the importance of Henry law constant? At the same temperature, different gases have different Henry law constant value, suggests that Kh is the function of the nature of the gas. Kh is the function of the nature of gas. Now, what the question they generally ask, what the question, you see the previous year question is, when temperature increases, okay, when temperature increases, what will be value of kh? Increase or decrease? You need to answer increase or decrease. Increase or decrease?
Sir, value will remain same only.
You need to explain now. You need to explain, or you tell me I should explain.
No, sir, because here it is mentioned already.
So
KH
what kh is
here
equal to p by x. P by x.
Slope is equal in both cases. So that is why K is equal to K.
But this graph is for the constant temperature is there. Okay. Okay. So this is the kh will increase, na? In the statement you see in the form of statement you see temperature increases. If you are increasing the temperature, so solubility will decrease. Yes or no?
Sir, what you told last time that was not audible.
Temperature increases. Temperature, if you are increasing the temperature, the solubility will decrease, na? Solubility of gas and liquid decrease. And this is inversely proportional, so kh will increase. So that what you are telling, that is correct one. See what is there here thing. Predict whether gas among the given pair of the gas will be more soluble in water. So kh value they have given. How much? 144. And here is 34. So you let me know that is which one will be more soluble, O2 or He? If you talk about P equal to KHX. So X is solubility, P by KH. Okay. So inversely proportional. Inversely proportional. So lesser the value of KH, greater is the solubility. So here you see the value is how much? 144. Here is 34. So this value is less. Less value is more soluble. So O2 is more soluble. Can't you understand this?
Yes.
Say properly. I don't know. You are saying yes, yeah, no. Your sound is not coming.
I will tell you.
Okay, but your sound is not coming proper. Here, 39. Question number 30. Read the question 39.
Predict which gas among the given pair of gases will not be soluble in water. O293 or O2 303.
Here, what is the temperature is 303. Temperature is 290 Kelvin, 293 Kelvin. Which is more soluble? Which temperature will be more?
Here, 303 Kelvin is more soluble.
So 293 will be our. You kindly concentrate, otherwise you will miss this one. From your answer, they are saying comment this one now. So O2 to less temperature already, lower the temperature, higher the solubility. In the term of Henry constant, lower the KH value, higher the solubility. This way also you can answer. Is it okay?
I did by the temperature.
Whatever you can. Explain painful condition known as bends with the help of Henry law. How can you explain the bends with the help of Henry law? Deep, if you are going deep, so solubility is more. If you are coming up, so pressure is come, solubility is less. Pressure is less, solubility is less. Okay? Pressure less, solubility less. So that is P proportional to X. Okay. Now the what condition they are talking about, that when the deep sea you are going more soluble nitrogen, more soluble, coming up in the form of bubble, it is coming, yeah, and it is forming, it is blocking the capillaries. And once the capillary is blocked, no blood flow will be there. And this
Yes.
medical condition is known as what? Bends. Okay. What is at high altitude? People suffer from the disease called anoxia. Okay, because they do not take the oxygen proper. Okay. Now, are you be able to understand this all the concepts?
Yes, sir.
Now go back to the here second slide here. Okay. Here the question on the Henry law. Okay. Where question already this is solved question, but let's try to understand. What concentration, so now here they are saying, what concentration of nitrogen should be present in the glass of water at room temperature? Assume at 25 degrees C, total pressure of 1 atmosphere and mole fraction of nitrogen is 0.78. KH is they have given here. So P is equal to what is there? KHX. This is there.
Yes.
KHX.
Yes, sir. Now
Here
into substitute.
uh,
Mole fraction given 0.78, and this one KH is of given 8.42.
hmm. But this is not given, na? PN2 not given, na? PN2. This is not given. PN2 is not given. Concentration of N2 in water is, they are writing KH into PN2. PN2. How they are doing this one? PN2 is equal to X into P total. P total. Do you know this one? Dalton's law of partial pressure. Dalton's law of partial pressure. Have you heard about this? Partial pressure. Have you read this one? Hmm?
Sir,
P,
only one question is there in the screen, sir. I am still able to see that one. Concentration of nitrogen.
PN2 is equal to X into P total. Okay. X
Extent
into
is 0.78 into 1 ATM. That means 0.
Okay. So PN2 is equal to, this is, let it the XN2 as it is. And they have given mole fraction, they have given somewhere. Mole fraction of nitrogen is point. How much they have given? They have given 0.78. 0.78. P total they have given 1 atmospheric pressure. Okay. What should be gas in water at glass of water at room temperature. So 1 atm is there. So 1 atm is equal to how much is there? 760 mmHg. mmHg. This we have to memorize. Already we have learned this one. So here we can write that is 760 mmHg. So if you are calculating this one, PN2, how much we are getting? 592.8 mmHg. Little bit tough here. Now, concentration of N2 in water. Concentration of N2 in water. What will be there? That is P proportional to what is there? P proportional to X na. This one is there. So this will be in the term of concentration. Partial pressure regarded as concentration. Because both terms are similar. So concentration is equal to what will there? KH into X. KH value they have given 8.42 into 10 power minus 7. And this one, if pressure you calculate, what this is coming? XN2, not PN2. This is XN2. What this is coming? XN2. PN2. PN2. Then what they are saying? PN2. So X is equal to, if you have, I will consider the solubility, concentration of N2 in water. What formula they are using here? Okay. Yeah, correct or
So
not?
using the KH Henry constant, it will multiply the partial question.
This is correct one, na? Formula. The same formula they are using x is this one. X is equal to what is coming? KH into P. Will it come? Will it come? P is equal to KHX. So how they are writing? X is equal to KHP.
Mm.
N2 in water. This is okay, no problem. P and 2, what the relation
Okay.
there? What relation is there? Okay, I will go through it. I will go through it. Okay, leave it. I will go through it. Here you can solve this one NCRT. This is the NCRT. Can you erase this whatever you wrote?
Into gas level through water 293 Kelvin. How many millimoles of
Hmm.
N2 gas would dissolve in 1 liter of water? Assume that N2 exerts partial pressure.
Hmm.
1 Given
Hmm.
Henry's law constant.
Hmm. Okay. So this one I am telling you, na, this one. This is a NCRT solve example. NCRT solve example. You can see in your solve example. Solve example. So here you see that is what the information they have given, Sanoy. This one volume is 1 liter. Okay. V is equal to 1 liter. Second one they are saying partial pressure of N2. PN2 is how much? 0.987 bar. Henry constant is given how much? 76.48. So, okay. Now, they are saying that is given Henry constant. Assume this one. N2. What they are asking, if N2 gas bubble through water 290, how many millimoles of N2? Okay. Millimoles they are asking. Millimoles. Okay. Millimoles they are asking. Okay. What can you do here? You see here. So P is equal to KHX. Can we write? Now, if you see that is X water, XH2O, how we calculate? 1 liter water means 1000 ml divided by molar mass 18. So 1000 gram divided by 18. So it is coming 55.5 mole. That you know, na?
Yes, sir.
So here what we can do here, that is x, first one you write x is equal to Pn2 upon Kh. Okay. Pn2 value there 0.987 by Kh value they have given here kilobar they have given 6.48 into 10 power minus 3. Kilobar means plus 3, not minus 3. Okay, we are converting into bar. Okay, now if you are solving this one, how much coming? 1.291 into 10 power minus 5. This mole fraction is unitless quantity that you must be knowing. Now moles of water that is they already given. So mole fraction, from the mole fraction, how to calculate this one? Mole fraction of N2. Mole fraction of N2. This is the solubility, na? Solubility. This is solubility. Solubility means this is there in the water. This amount is there in the water. So mole fraction of N2. Mole fraction of N2. How can you calculate mole fraction of N2? So that is moles of N2. N2 I am writing N2, NN2 upon NN2 plus what will be there? NH2O. Is it? Because millimole they are asking. So here what we can do somewhere, this case, N1 we don't know moles of N2 and divided by N1 again we don't know plus H2 we know 55.5. In denominator, this value will be very less. So Xn2 is equal to N1 by 55.5. This will be there. X value already there. How much? This value is there. 1.291 into 10 power minus 5 equal to N1 divided by 55.5. So N1 is going to come. How much it's coming? If you multiply 1.291 into 10 power minus 5 multiply by 55.5, So it is coming 7.17 into 10 power minus 4. Of this, they are the moles. Now they are asking to convert into the millimoles. To convert into millimoles, what we have to do? 1 mole equal to how many millimoles, Sanway?
10 power minus
10 power?
10 millimole.
Hmm.
1 millimole means 10 power minus 3 moles.
10 power minus 3 or plus 3.
Minus 3, sir.
If you are writing the minus 3 already, it is minus 3 is there, then how we will convert? This is moles. And if you divide by 1000, multiply by 1000. So if you are multiplying by 1000, so this value you will get. How much? 0.717 millimoles. Millimoles. This will come. This is an NCERT problem. Once you again go through, I hope you could not understand this one. Once you again go through this one. Getting my point?
Yes.
Or is there any problem you may ask again in this question?
No, sir.
No. But you practice once because they are the example. The same question asked here. Okay, these are there. So what I am doing here, I am sharing you the problems on Henry Law. These are the problems on Henry Law. Some are the solved problems, some are unsolved problem. Like the downside is there, these are the unsolved problem. These are. Okay? Getting?
Yes, sir, but first, should I not complete the NCERT? First of all, everything.
What? This is the Henry Law. Henry Law you completed na today. Henry Law completed.
Yes.
So you practice the problem on Henry Law na? Can you practice?
Yes.
So I am giving you the
Yes, sir, I
PDF.
can practice.
I am giving you the PDF. You practice the problem on Henry Law. And in that case, if any case you are facing the problem, tomorrow you text me that this problem is facing so that we will discuss tomorrow only. Okay. And next class, that is next class, we will study the Raoult's law. Okay, Raoult's law that you are asking, Raoult's law for what is liquid solution. Liquid solution. Getting my point? Liquid solution.
Yes.
So for today, let it be okay. And silently you tried some of the problem. Okay. On the Henry Law. Henry Law actually generally come 3-mark questions. Getting?
Yes, sir.
So, okay. Nah? Today for today it is okay. Tomorrow we will study the Raoult's law. Got it? Okay, na?